The hunt for interesting exoplanets and life forms somewhere out there in the vast expanse of the universe keeps going. No stopping here. We're basically searching for a second Earth, a planet that's similar to our home, and where we could finally find some space friends. Hey, we're not picky. Any form of life is fine, even some bacteria-sized organisms. And this search has mostly been going on in the habitable zone around other stars. We call this the Goldilocks zone. That's a region where conditions are barely just right for liquid water to exist, whether we're talking about the surface of a planet or a moon. The hotter the star, the more space we get to explore, because its habitable zone spreads far away. And in terms of endless space that we yet know so little about, that's a lot of work. That's why we're fans of red dwarfs. There are hundreds of billions of stars in our galaxy, and probably around 80% of them are red dwarfs. These tiny stars are much cooler than our sun. It means that their habitable zones are much smaller and closer to the star, so we know better where to look for planets. They're circling around their central star, and at some point, bingo, there it is. They pass in front of it and block out some of its light. The Kepler Space Telescope has already helped us find thousands of planets using this method, and most of them are orbiting around red dwarfs. Some of these planets are similar in size to Earth, and many of them could have nearly 25 times more water than our entire planet. Let's move to these planets scientists discovered, though. I want to show you something special. So, you've heard of super-Earths, right? More massive than Earth, lighter than Neptune, can be made of rock, gas, or a mix of both. Some of them have thick atmospheres, while others have thin or no atmospheres at all. You may also have stumbled upon mini Neptunes by now too. They're almost as big as Neptune, and unlike normal gas giants, they have solid cores. That way they can support a dense atmosphere with water and some other chemicals necessary for life. There's also hot Jupiters. Those are pretty cool, but only if they're far away from us. You know that one annoying and unpredictable neighbor you can never get rid of or figure out what they're gonna do? Yeah, that would be a hot Jupiter, with strong gravity that can destabilize the orbits of smaller planets or other space bodies in the system. If we had such a neighbor, there would be more comets and asteroids hitting our surface. Luckily, our Jupiter is a good and peaceful neighbor that minds his own business, at least for now. But let's leave all these and many other planets out there alone now. Imagine traveling around in your spaceship and coming across a giant eyeball just floating there in the darkness of space and staring at the central star of that solar system. It's not a monster. Hopefully, space friends we'll make in the future won't look that big and scary, so it won't blink or turn towards you as you come closer. It's actually a planet. A little bit bizarre, but still very cool. And yup, you guessed it right, we call such eyeball planets. Now, eyeball planets are surprisingly common. Plus, some normal planets can potentially turn into them too. Eyeball planets form when matter and dust accumulates around a star and gradually turns into a solid object. It starts spinning, and over time, the gravity of the star pulls on the planet and slows its rotation until it becomes tidally locked. That means one hemisphere always faces the star, while the other is in darkness all the time. Now, we have a good example of this phenomenon near us, too. Our moon makes a circle around Earth once a month. It takes the same amount of time to turn a single time on its axis. That way, we actually always see the same face of the moon. Who knows, maybe the other side is even prettier, if you like craters and stuff. So, one of the most interesting things about eyeball planets is their appearance. If they had water on their surface, the side facing the star would have clear, bright blue oceans, the ones we'd want to visit if we ever got a chance to go on an interstellar vacation. And the other side would be more for adventurers who like harsh and challenging surroundings. Since it's in constant darkness, it would most likely be very cold and covered in ice. We've discovered so many planets outside of our solar system in the last 30 years. Super-Earths are, of course, especially interesting. It seems that many of them are not that pleasant, since they're pretty hazy and cloudy. It means it's harder to spot any life there, but some scientists still think they're promising spots when it comes to finding life beyond our solar system. eyeball super-Earths would be a good start. These planets are probably covered in large oceans. On the cold half, where the eternal night reigns, you'd experience Arctic conditions. I feel cold just looking at this. But the day side is my jam. Plus, it sounds promising when it comes to finding life. You know, with all that sunlight, oceans and stuff. One of the good examples where scientists are looking for life is an eyeball super-Earth that lies in a habitable zone of the closest star to our solar system, called Proxima b. Its day side could even have conditions and an atmosphere to support some form of life. There could be a large deep ocean covering its surface. It could be really salty, but some forms of life could still survive there. Check out the Dead Sea on Earth. It's extremely salty, but some bacteria have still evolved to live there. And they're probably doing well, having their own world and all that. I mean, it's not crowded because there are no animals there. Fish that accidentally end up in the Dead Sea won't survive there for long. So, similarly, it's possible that bacteria or some other forms of life could exist in this potentially very salty ocean on Proxima b as well. But the open ocean on Proxima b could be tricky. On the dark side of the planet, the ocean could freeze and sea ice could drift into warmer waters. That way, the ocean would cool and more of it would freeze, even on the sunny side. The only way to prevent this global freeze-over would be an atmosphere with a lot of greenhouse gases like carbon dioxide. This kind of atmosphere would trap the heat from the planet's surface and wouldn't allow it to escape into space, like what happens with Venus, the hottest planet in our solar system. Without an atmosphere with greenhouse gases, the surface of Proxima b would be much colder, so it's possible that the planet would completely freeze over. The opposite scenario could also be possible. Warmer waters could serve as a transporter of heat from warm to cold regions. We don't know much about the conditions on the planet yet, so Proxima b could range from a frozen wasteland to a hot, hazy world, depending on many factors. So yeah, an eyeball planet within the habitable zone sounds promising, but its surface can still wildly range from a frozen desert to an endless ocean. Some experts believe that drifting sea ice might cool many exoplanets out there, and they can't turn into eyeball worlds. Instead, many just become sad, dark snowballs, completely covered in ice. A cool spot to spend your interstellar winter holidays, but not a place where you'd hope to find life, unfortunately. Some studies show that even Earth may have gone through some snowball stages many times in history. One of those happened around 2.2 billion years ago. I wasn't around, while the other one hit the planet 630 million years ago. During these phases, all of our beautiful oceans were covered with snow and sea ice. Perhaps even the continents were just thick ice sheets, at least on the surface. Alright, enough of the freezy icy stuff. I need some hot chocolate. Our universe is full of both amazing and terrifying things. You already know about quasars, black holes, dark matter, and so on. But how about the horrors of space that you haven't even heard of? Would you like to visit the most bizarre worlds in the universe? And it's not me who made this list, but NASA themselves. Welcome to the Galaxy of Horrors, NASA's awesome Halloween collection. Please join me on a journey to some planets and tell me which ones you would consider the most horrible. Buckle up. Our first destination is a gas giant called TRAPPIST 2b. It's located 750 light-years away from us. If we used a regular spaceship, it would take us about 10 million years to get there. TRAPPIST 2b orbits a yellow dwarf, a star similar to our Sun. It also weighs about 1.5 times more than Jupiter. So, what's so special about it? Well, if you're afraid of the dark, you definitely don't want to visit this place. It's the planet of eternal night, the darkest one of all the planets known to us. But it's not that far from its star, so why is that? The thing is, the surface of TRAPPIST 2b reflects light even worse than coal does. Because of this, it seems that there's no light at all. If you were flying across the surface of this planet, it would be like walking with a blindfold on your eyes. Oh wait, actually there is some light. An eerie deep red glow surrounds the surface of the planet. This glow is created by the burning atmosphere. which makes Tres 2b a scorching planet. The air there is even hotter than lava. Oh, but if you think that was bad, let me show you the next place of our horror journey. NASA wasn't beating about the bush while nicknaming this one. Now, we're not just talking about one planet, but three at once. They're also located quite far away, 2,300 light years from the Sun. We would have reached them by ship in about 35 million years. All the planets are in the constellation Virgo, and each is extremely light, much lighter than the Earth. These three exoplanets are called Poltergeist, Dragger, and Phobator. Cool names, huh? It's because each of these planets is about to become a ghost soon. The thing is, they don't revolve around a star, but around a pulsar. Pulsars are rotating neutron stars with an extremely powerful magnetic field. In simple words, these are the stars that exploded one day. After the explosion, they usually emit such a powerful pulse that it causes the star to rotate at an unimaginable speed, several thousand rotations per second. At the same time, they constantly emit electromagnetic pulses that affect everything around them. So, you've probably already guessed what's happening with our zombie planets. They are slowly, gradually being destroyed under the gigantic influence of radiation. One day, they'll disappear without a trace. Ghost-like planets orbiting an undead star? Yeah, Zombie World is a fitting name. It's also not surprising that scientists nicknamed this pulsar Lich, despite the long official name. Well, at least these guys stick together on their really strange. It didn't just revolve around its star, it lived inside the star. This cosmic miracle is called KOI 55b, or Kepler 70b. This planet is very far away from us, 4,000 light years. It would take about 70 million years on a spaceship. It's twice as light as Earth, and fully rotates around its star in just a couple of hours. A long time ago, it was an ordinary Earth-like planet, about the size of Jupiter. It was peacefully and calmly orbiting its red dwarf star, KOI 55. But everything changed about 700 million years ago. Perhaps you've heard that in a couple billion years, our sun will begin to expand into a huge star, absorbing everything in its path. Well, this is the fate of red dwarfs. Sooner or later, they increase, turning into incredibly hot blue giants. The same thing happened with KOI 55. This star began to increase in size and heat up in temperature, gradually turning into a blue-white giant. It was ready to devour its nearest planets. But KOI 55b didn't care about it. When the star reached it, this planet just settled inside. And moreover, after some time, it left its star, simply returning to the new orbit. How is that even possible? Life inside its star turned KOI 55b into a red-hot round stone. It's one of the hottest planets we've discovered so far. The temperature on it reaches 12,000 degrees Fahrenheit. It's hotter than the Sun, which is, let me remind you, an actual star. And for some reason, it's still alive and lives as if nothing happened. Unfortunately, sooner or later, the planet will disappear anyway. It's slowly evaporating itself due to the incandescent atmosphere. But still, it somehow managed to survive the journey through the star, which isn't typical for regular planets, to put it mildly. I envy this willpower. However, not all planets are so lucky. Some are gradually being destroyed by their stars, and there is even an entire system among them. This last planet is a sad loner. It's located 870 light-years away from us. The journey by ship to it would take about 25 million years. This planet is about 1.5 times more massive than Jupiter. This is a very sad, dark planet. A doomed gas giant, which is very similar to hot Jupiter, orbits its star all alone. At the same time, it's located so close to its star that its orbital period takes just one day. Of course, because of this proximity, the star gradually absorbs WASP-12b. The scorching heat of the star is slowly destroying and devouring the planet's atmosphere. The planet has only around 10 million years left. But what's more interesting, because of this stretching, WASP-12b acquired the shape of an egg. It doesn't even resemble an actual planet anymore. It's also very hot. The surface temperature of the gas giant reaches 4,000 degrees Fahrenheit. Also, A spectrograph of cosmic origin, or COS for short, found that the planet exchanges matter with its star. They're located so close that they give each other part of their chemical elements. This is a common phenomenon in closely spaced binary star systems. But this is the first time scientists have seen this in a star-planet relationship. What a unique system. To be honest, if I was guaranteed complete security, I'd be excited to visit at least some of them. What about you? Please let me know in the comments. TRES-2b is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first, because it's closest to the star, is different in a most horrible way. 55 Cancri E is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side, and between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. HD 189377b, I'm not gonna say that again, is the only exoplanet in the orbit of its star, and at first glance it looks quite pretty. Blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular, it's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70 is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our sun. It was lucky to survive spending time inside the star, but it's evaporating now, and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours. And those clouds I mentioned are not made of water, but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave or crazy enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1800 degrees, perpetually blown over with winds reaching 600 miles per hour. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds, and when those cool down, they fall on the surface in the infernal rain of molten iron. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. TRES-2b, or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first, because it's closest to the star, is different in a most horrible way. 55 Cancri E is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side, and between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, I'm not gonna say that again, is the only exoplanet in the orbit of its star. And at first glance, it looks quite pretty. Blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better dark. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler 70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our sun. It was lucky to survive spending time inside the star, but it's evaporating now, and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you? My mother. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you ask. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours. And those clouds I mentioned are not made of water, but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave or crazy enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw there, Thumbworth. Still, if it has a rocky core, it might generate some heat. So there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Karat Exo 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. The sun's heat is beneath our feet. Scientists have figured out that Earth's core is actually as hot as the surface of the sun, around 10,800 degrees Fahrenheit. One of the reasons it's so incredibly hot down there is because Earth is still shedding heat from when it was created billions of years ago. Also, when an object as big as Mars slammed into the young Earth, it not only created the moon, according to one theory, but melted the surface of the planet. A lot of that extra heat is probably still stored inside the core. But there's no need to worry. The planet's core is harder for us to access than it is to probe the surface of Pluto. In fact, chances are we may never develop technology that could physically reach the core. There's no air on the moon. But then, how can it be rusting? Scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. Even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds, although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Mars has two moons, Phobos and Deimos. In the next 30 to 50 million years, Mars's gravitational forces will tear Phobos apart, and it will likely result in the formation of a ring around the planet. The Earth is the densest in the solar system. At the Earth's center, there's a core that takes up 15% of the planet's volume. It consists of two parts, the outer and the inner core. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles, which makes 20% of the entire Earth's radius and 80% of the Moon's radius. The 1,500-mile thick outer core is liquid. It also consists of iron and nickel, but it's not under enough pressure to be solid. Mars houses the biggest volcano in the solar system. While everything seems to be calm on Mars nowadays, in the past, some sort of force caused enormous volcanoes to form and erupt. One of these volcanoes is Olympus Mons. It's 16 miles tall, which is the height of 3 Mount Everests, and 374 miles across, making it about the size of Arizona. A volcano grew to such a gargantuan size because of the weak gravity on Mars and the lack of tectonic plate movement. Gravity is not the same everywhere. The rocks, metals, and other minerals and substances that make up the planet are packed into the ground more tightly in certain places than in others. This has surprising consequences. Gravity varies slightly depending on where you are. You weigh 0.5% less standing at the equator than you do at the poles. In most cases, that's a difference of less than 1 pound. How high up you are also has an effect. So, if you were at the top of Mount Everest, you'd also weigh slightly less. Just don't look down. Earth's toughest living thing is so small you can't see it. Water bears, also known as moss piglets, are cute little creatures with 8 legs and swashed-up heads that are less than 1/100th of an inch in length. Despite their microscopic stature, they can basically survive anywhere. They prefer bits of wet moss or the bottom of a lake, but they won't complain if you put them somewhere really uncomfortable. They can endure extreme cold and incredible heat, and survive both huge pressure and high radiation. Some of the little bears once even managed to survive unprotected in outer space for 10 days without a problem. That is tough. They handle all these things by rolling up into a ball and hibernating, which reduces their need for oxygen and food. The moon's gravity is about 17% of that on Earth. If you weighed 200 pounds on our home planet, on the moon, your weight would decrease to a mere 34 pounds. You would also be able to carry stuff 6 times heavier than what you can carry on Earth. It would also be easier to walk on the moon's surface, but it would be more dangerous too. Your feet inside a heavy spacesuit would sink into the lunar soil up to 6 inches deep. But let's imagine you decided to skip the tedious process of walking by leaping through the air. Then you'd likely lose control of your jumps in no time. Plus, the moon's surface is littered with deep craters. It would be a tough feat to avoid all of them. You can see solar eclipses because even though the moon is 400 times smaller than the sun, it's also 400 times closer to Earth. So it's perfectly capable of obscuring the star. But in 50 million years, I won't be around then. The moon won't be able to block the sun completely because of the satellite's changing orbit. A full NASA spacesuit costs an unbelievable $12 million. Yeah, I can believe that. 70% of this hefty sum is for the control module and backpack. At the very center of Uranus, there's a rocky core, small, just half the Earth's mass. Compared to other planets, Uranus's core is rather cool, 9,000 degrees Fahrenheit. An ice mantle surrounds the solid core, and that's the largest portion of the planet, about 80%. It's also not the ice you might be thinking about. It's a hot, dense fluid made up of water, ammonia, ice, and methane, sometimes referred to as a water-ammonia ocean. Uranus's atmosphere is mostly hydrogen and helium, but it has its blue-green color because of methane gas that absorbs the red light. The ocean on Jupiter is larger than any other in the solar system. But unlike Earth's oceans, it's made not of water, but of metallic hydrogen. The ocean's depth is a mind-blowing 25,000 miles. That's almost the same as the distance around Earth. Venus is a champ when it comes to volcanoes. The planet has about 1,600 major ones, but none of them is known to erupt. There's a supermassive black hole 250 million light-years away from us. It hums the deepest sound ever detected from any object in the universe. It's 57 octaves lower than the middle C on your piano. That's 1 quadrillion times deeper than what we can hear. Mercury is a few billion years old. In 2016, scientists discovered some abnormalities on the planet's surface, showing that it's getting smaller. After more research, they found out that Mercury hadn't finished cooling down yet. There are planets that aren't bound to any star orbit and aimlessly wander through outer space. Among the most spectacular-looking space objects are pulsars. Pulsars are a type of neutron star. They shoot out some of their material almost at the speed of light. Regular pulsars spin at a reasonable speed, between 1/10 to 60 times per second. But millisecond pulsars can spin at an impressive 700 times a second, which is way too fast for the human eye to even process. As they spin, they emit a beam of radiation from their axis that looks like the light from a lighthouse. Astronomers can notice pulsars when they face Earth, since it looks like a light being shined on our planet. When the light shines elsewhere, the pulsar can't be seen. Our sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Saturn's rings are very thin compared to its size. If you had a scale model of the planet that was 3 feet wide, the rings would be 10,000 times thinner than a razor blade. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot. Okay, here you are, in the middle of the ocean. It's endless, but you can't see it, because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kinda dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans, its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.025%. Exactly. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It can reach up to 20,000 Earth atmospheres. Very crushing. Now, it may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons. Although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it'll have a rocky surface. But if it's bigger, it'll turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small dim dot. This dot turned out to be the red dwarf star Gliese 1214, an unremarkable, completely ordinary star that's 5 times smaller than our sun and 300 times dimmer. Scientists wouldn't worry about it at all. But back in 2009, they noticed that this star had one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier, but at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it, but it wasn't a gas giant either. So there was only one option left. It was covered in water and ice, and that's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Gliese 1214b is very close to its star. It's only 0.014 astronomical units away, which is less than the distance between the moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250 to 535 degrees Fahrenheit. Ooh, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different. More like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam. And there, you suddenly find yourself in the water. What? But when did it happen? Well, that's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely, this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So that's it for the creepy Gliese 1214b, and not an Airbnb in sight. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of super-Earths. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here, we were a little luckier. This world won't be just a giant puddle and some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though. This ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but 2 at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the sun. And it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? All right. I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars. So, potentially, yes, there might be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There should also be some microelements and some minerals. And unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up. There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability that they'll bring something like this into the ocean and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there. But if it exists, then surely something could have originated there. Let's hope that new research with powerful telescopes will allow us to find out the truth. And who knows, maybe one day we'll be able to visit such a planet ourselves. So check this out. Astronomers have discovered an exoplanet they're calling Super Saturn. It's got rings over an AUY. An AU is the astronomical unit, the distance between the Sun to the Earth. That's an incredibly huge ring system, hence its name. Super Saturn is being called Mamajex object after the astronomer who led the team to whom we owe the discovery. Professor Eric Mamajek of Rochester University in New York found Super Saturn while scouring through data downloaded from wide-angle transit observations. WASP is the acronym for Wide Angle Search for Exoplanets. It's an ingenious project developed in the year 2000 by astronomers at Queen's University in Belfast, Northern Ireland, and St Andrews University in Scotland. Using 4 telescopes, the CCD video cameras on the scopes record the slight dimming of starlight caused by objects passing in front of stars. This is called the transit method of exoplanet detection. So, for example, the planet Venus transits across our view of the Sun every couple hundred years. A black dot, the silhouette of Venus, is visible, crossing in front of the Sun as Venus passes between our line of sight and the Sun. This tiny eclipse causes the amount of sunlight coming to Earth to be reduced by a minuscule amount, also known as teeny tiny. The same is true for all the stars in the Milky Way that have planets going around them. Exoplanetary transits in front of stars must be in direct line of sight with Earth for the starlight to be dim. Such transits do not occur very often. That's why thousands of stars must be looked at simultaneously for as long of a duration as possible, between 4 and 8 hours a night. WASP was created to stare continuously at as wide of a range of stars as possible. Maybe one of them would show an exoplanet transit. That translates into a lot of data being produced, about 40 gigabytes per viewing session. Computer scientists at Leicester University in England developed a computer program to store the data and generate photometric graphs of the light intensity of each star. Open University, also in England, joined the WASP project, took this data, and made it available for research by astronomers worldwide. The graphs of the intensity of starlight show that changes in its brightness are called light curves. These graphs have 2 axes. One is in the timeline axis, the other one is the intensity of light. As the object, considered an exoplanet, though it could also be a brown dwarf star, crosses in front of the star, the timeline axis keeps track of how swiftly it is moving. It tells us how close the object is to the star, while the brightness axis keeps track of how much the starlight dims. This way, we can find out how large the object is. Now, obviously, big objects will dim the light more and be easier to detect. At present, Earth-based equipment is not sensitive enough to measure the dimming caused by planets as small as Earth. Neptune size and larger ones are the limit for WASP. However, the James Webb Space Telescope, which is now in operation, has a much greater sensitivity and will be able to resolve the transits of Earth-sized exoplanets. Now, I know you want me to get to Super Saturn, but there's something else you should be familiar with before we get there. If the exoplanet has an atmosphere, or, in the case of Super Saturn, a ring system, the starlight from the star the planet is transiting will shine through the atmosphere or ring system, and that can be detected too. The light curve will show less dimming in the photometric data, because not all the starlight is being blocked. Some light is still getting through the atmosphere or rings. This is important because it gives astronomers a reading of the atmosphere. The James Webb Space Telescope is fitted with spectroscopes that can determine the gas content of the transiting exoplanet atmospheres: oxygen, methane, carbon, etc. The WASP project has been really catching on. There's a Super WASP project now consisting of WASP North and a WASP South. One looks at the sky above the northern hemisphere, the other looks at the sky above the southern hemisphere. There's also a next-generation transit survey, NGTS, based on the WASP project. It's automated, so astronomers don't have to stay up all night sipping coffee, but they can if they want to. Located at the European Southern Observatory in the Atacama Desert in Chile, the NGTS scans millions of stars and has discovered over 100 exoplanets, down to a size as small as 3 times the size of Earth. NGTS has started a Planet Hunters Club on social media. Citizen scientists can search the online database of light curves and perhaps discover your very own exoplanet. What had been a strictly British effort started by 1 or 2 astronomers is now a worldwide phenomenon. With the ability to read the spectroscopic signatures of atmospheric gases during exoplanet transits, a new idea emerged: technosignatures. That is, specifically identifying gases in exoplanet atmospheres that are produced by civilizations. The James Webb Space Telescope can do this. Gases from pollution, such as chlorofluorocarbon CFCs, can be seen spectroscopically if present. Tritium from fusion reactions, if they have them, can also be detected, along with heat patterns from cities on the planet's surfaces. Technosignatures is a recent concept that originated after the WASP project started. Who knows what it will turn up? Now, let's get back to Super Saturn. The star that Super Saturn orbits is J1407, a small, dim, sun-like pre-main sequence star of the 13th magnitude. Well, the human eye can only see stars to about the 6th magnitude, and each magnitude is 2.5 times dimmer than the previous one. So, it's not an exceptional star, just another telescopic star out there in the Scorpius Centauri region of the night sky. J1407 is a young star that hasn't yet settled into its stable, long-duration phase. This is important because Super Saturn, officially J1407b, is showing signs of having a ring system in an early stage of development. Super Saturn's light curve was tucked away in the mountain of data from the Super WASP project. Professor Eric Mamajak and his associate Matthew Kinworthy of Leicester University studied the data thoroughly and produced a detailed report on it. Knowledge depends on good data. The horizontal axis of J1407b's light curve, the time axis, is what's causing all the hubbub. It took Super Saturn weeks to transit across in front of its parent star. 56 days to be exact. Planetary ring systems that we are familiar with in our solar system orbit right around the equators of the gas giant planets and are very thin, from only a few meters thick down to a few centimeters. In a telescope, Saturn's rings will seem to disappear when the planet is at zero inclination toward Earth. Saturn must be inclined at an angle in relation to Earth to see Saturn's beautiful ring system. It's something everyone should make a point of seeing. Saturn in a telescope. If Super Saturn's rings block most of the light from J1407 for 56 days, it means that the planet had to be orbiting at a steep inclination to its star. If it were at zero inclination, we wouldn't see the rings blocking any light. Therefore, the orbital time could be determined, 10 years minimum to 200 years if the orbit is highly elliptical. The superplanet itself is calculated to be 24 times the mass of Jupiter, which means that if it is gaseous, it could be a brown dwarf star. Super Saturn appears to have a Mars-sized object orbiting around it, because there is a huge gap in the rings that was most probably cleared out by a large object. The Cassini division in the rings of Saturn is where the moon Mimas has cleared out a path through Saturn's rings. The light curve of Super Saturn has only been observed once. All the exoplanet detection systems are keeping an eye out for it to come back around J1407. No one knows when that will occur. Some astronomers have suggested that J1407b is a brown dwarf star system in itself, merely passing in front of, but not connected to, star J1407. An orbital reappearance of Super Saturn would disprove that conjecture. The center region of Super Saturn blocked out all the light from its primary star. This is what indicates that the ring system is new and in an early developmental phase. Over time, the very dense ring mass close to the planet is expected to thin as all this matter gets absorbed into the planet or ejected into space. This is what has happened with our solar system's gas giant planets. The Mamajek object is a shocker. Never before or since has a light curve been detected like Super Saturn's. Super Saturn has added a new chapter to our understanding of the formation of ring systems. So, here's to you, Super Saturn. Hope to see you again soon. Now, Jupiter used to be flat and look like an M&M candy. Now I'm hungry. And it wasn't the only flat pattern in our solar system. Turns out there are tons of things that can go wrong during a planet's formation, like locking up to the sun or getting whooshed into open space. Let's check it out. The Earth isn't flat, but Jupiter might have been. Instead of being a big round ball, gas giants in our system might have started more like flat pancakes. Jupiter is one of the oldest of our neighbors. It's 4.6 billion years old, just like our sun. And when it was just a baby planet, it likely formed through a process called disk instability. It all begins with stars. When a star is forming, it doesn't look like a round object. It's more like a big disk of stuff. During this stage, really hot winds made of charged particles blow out. The dust in that disk contains stuff like carbon and iron. Some of them collide and stick together, forming bigger objects. Dust turns into pebbles, pebbles turn into rocks, and rocks bump into each other, getting bigger. Gas in the disks helps all these solid bits stick together. Some break apart, but others stick around, and they're the ones that become the basic pieces of planets. They're called planetesimals. Even gas giants like Jupiter started off as tiny specks of dust, smaller than a human hair. Eventually, they formed their own big ring-shaped disks of gas. They began to spin around our sun, growing bigger by gathering gas in rafts like snowballs. Gas giants are special. They were born from the colder parts of the disk. In cold areas, molecules are slower, which makes them easier to grab. In these places, water could freeze, and tiny ice pieces stick together and are mixed with dust. These dirty snowballs gather up and then form cores of huge planets, like Jupiter, Saturn, Uranus, and Neptune. In the warmer areas closer to the star, rocky planets like Mercury, Venus, Earth, and Mars start to form. After the icy giants were born, there wasn't much gas left for these smaller planets. It might take tens of millions of years for these rocky planets to form after the star is born. And our sun was growing at the same time, sucking up nearby gas and pushing faraway stuff even farther out. After billions of years, the disk changed completely, turning into a round star with a bunch of planets, dwarf planets, asteroids, moons, meteoroids, and comets around it. Recently, simulations showed that these protoplanets, as these early dust balls are called, don't start off looking like the planets we know. In the case of gas giants like Jupiter, they look more like squashed balls or M&M's candies, not the peanut kind. When the sun was young, the disk of gas and dust surrounding it cooled down and became unstable. It started breaking into big chunks. These chunks dramatically collapsed together under huge gravity to create Jupiter. It became a round gas giant over time. There are a lot of oddities that can happen during that process of planet formation. Ever wonder why Venus or Uranus spin in the opposite way compared to other planets? Usually, when things form from a spinning disk of gas, they tend to spin in the same direction. For example, if you spin a bunch of balls on a string, they all twirl in the same way. So, theoretically, all planets should spin in the same direction too. But there are a lot of fast-moving objects like comets and asteroids in our solar system. When they smash into planets, especially during their early days, this collision might send the planets to spin in the opposite direction. Venus and Uranus probably survived a massive collision. Luckily, they weren't repelled to outer space. The gravity from the sun and nearby planets hold them back into place. There are also so-called tidally locked planets. These are celestial bodies that spin in a way where one side always faces their star, while the other side remains in perpetual darkness. So, one side is always very hot, while the other is extremely cold. If we were on a planet like that, we would only be able to live on a thin line in between. These planets form when they're very close to their star. The gravitational forces are extremely strong, and over time, these forces slow down the planet's rotation until it matches the time it takes to orbit the star. Imagine you're spinning in your chair. Someone comes up to you and, holding onto your chair with their hands, starts spinning with you. This way, you'll always face each other. Tidally locked planets kind of work like that. Our moon is tidally locked to our Earth, which is why we only see one side of it. We've discovered more than 5,000 planets outside of our solar system, called exoplanets. Some of them have very strange orbits. For example, planets with incredibly long orbits, thousands of years to make one trip around the star, or very wonky, comet-like orbits, or so-called hot Jupiters. They're super close to their star, way closer than Mercury is to our sun. But these planets couldn't have formed where they are now. As their solar system evolved, they changed their positions for some reason. This rearranging is called planetary migration. There are three main ways this migration happens. First, because of the gas and dust spinning around the planet. When a planet is bumping into this stuff, it can create spiral patterns in the gas. These patterns can either push the planet closer to the center or farther away, depending on how they mix together. It's called a gas-driven migration. This is what Jupiter experienced when it moved closer to the Sun billions of years ago. I wasn't around then. This also explains the existence of hot Jupiters. Second, big planets can shove the smaller ones, changing their paths. Third, the star's gravity can tug on the planet, making its orbit more circular. Ever heard of rogue planets? Imagine a lonely planet floating in the vastness of space without a star to call home. They're like the wandering nomads of our galaxy, doomed to drift around forever. And there are so many of them, there might be more free-floating planets than ones that are tied to stars. We're talking trillions of rogue planets hanging out in our Milky Way galaxy alone. They're often as massive as our biggest planet, Jupiter, but most of them might be Earth-sized. Some might even have thick atmospheres that keep them warm, even though they're far from any star. Some of them might have wild auroras, while others could host moons with liquid water, a potential haven for life. There's even a chance that they might contain extraterrestrial life. These planets might bump into other stars or even entire planetary systems as they journey through space. Sometimes they might get caught in a star's gravity for a while before getting flung back out into space. But how are they born? Sometimes during this chaotic process of planet formation, not all planets can manage to stay close to their parent stars. Some of them get kicked out of their solar systems due to powerful gravitational interactions with other planets or passing stars. These ejected planets become rogue planets. In 2012, astronomers found a solar system from the very beginning of the universe. This system included a star and 2 planets. We called it a fossil system. The star is super old, about 13 billion years, almost as old as our entire universe. It was mostly made of just hydrogen and helium. This is unusual, because planets usually form from clouds of gas that contain heavier stuff. That's when we figured out that the way planets formed before was different from how they form now. We know that stars with more metals are more likely to have planets. In astronomy lingo, metals means any chemical element other than hydrogen and helium. But in the early universe, there weren't many metals. Most of them were created inside stars and then spread out into space when those stars blew up. So, when did the very first planets form? This newly discovered system helps answer these questions. Its 2 giant planets are orbiting a star that's incredibly low in metals and extremely old. This should be really rare, if not impossible, but they exist. This means that maybe there are more planets in metal-poor systems than we thought. Studying them will help us learn more about the history of planet formation. Magma oceans, supersonic winds, scorching hot days, and instead of rain, a bunch of rocks falling on your head. Just another one of those days, huh? Astronomers recently discovered a new super planet out there. K2 414b is an exoplanet that's around 200 light-years away and in serious need of a new name. An exoplanet is just a fancy way of saying that a planet orbits its own star in another solar system. The Earth orbits the Sun, so this planet has its own orbit party going on. So what makes K2, bunch of numbers, so scary? Picture our beautiful little blue planet Earth. Now imagine that all the volcanoes in the world suddenly erupted at the same time, and lava covered the oceans and seas. Fiery hurricanes, thousands of times faster than normal, blow all over the place, 24/7. And it starts raining rocks every now and again. Rocks, like on your head, thankfully not in your head. This scary planet came into our lives about 2 years ago. Scientists are still studying it. So, what's a typical day like? For starters, you can forget about breathing. Oxygen decided to take a pass on this planet. You'd have to get used to sodium, silicon monoxide, and silicon dioxide, which is, as you guessed, not great. And that's just scratching the surface. Who knows what other chemicals are lying around? And yes, magma oceans. The planet's surface is covered in molten magma as far as the eye can see. This lava planet orbits really close to its star, which is why the surface is like a fireplace. The closest planets to our sun are Mercury and Venus, but this planet's even closer. And what's even more weird is that half the planet is in constant daytime, the other half night. It's tidal locked, just like our moon is. No matter how long you stare at it, you'll never see the other side. That's why the all-day, everyday scorching fiery side is so hot and overflowing with magma oceans, while the other side's in a constant state of deep freeze. If the magma doesn't burn you, you've still got big problems, and please don't look up, it's raining rocks. On Earth, water turns to steam, rises up, becomes clouds, cools, and falls as rain. Over there on planet Fireball, it's exactly the same, except for it's rocks, people. The planet's so hot it vaporizes rocks. Oh, and don't forget the supersonic winds with speeds up to 3,000 miles per hour. Imagine your hat getting blown off your head at 5 times faster than an airplane. The strongest wind on Earth was the tropical cyclone Olivia that hit Australia. It was blowing at 250 miles per hour. Now imagine 12 times that. On the sunny side of the planet, you're looking at a roasting 5,000 degrees. The hottest it ever got on Earth's surface was in California, 135 degrees. It's pretty common for it to get near that temperature in the Sahara Desert, but that kind of heat's not exactly enough to make rocks evaporate. If you grew up near a desert, you already know how dry and hot it always is. But did you know that deserts can reach freezing temperatures? A desert, by definition, is a large area with little or no rainfall. That means no water vapor to keep the temperatures from going insane. In the daytime, the sun heats up the desert like an oven, but when the sun sets, the heat packs up and heads home, and it can get really cold. Some deserts have even reached minus 40 degrees at night. But wait, shouldn't deserts have snow that's that cold? Well, some deserts have had a bit of snow here and there, but because there's no water vapor, there can't be that much snow. Just dry, freezing, sandy Sahara nights. Now, the Sahara Desert's actually not the largest desert on Earth. It's Antarctica. 5 million square miles of icy dryness, almost no people, and a whole bunch of cute penguins. Penguins technically live in the desert. Back to the Fireball planet, this time the night side. Never-ending darkness and extreme cold, about minus 330 degrees. Add in some supersonic winds. Earth's coldest, minus 130 degrees at a research center in Antarctica. So, how does this jalapeno pepper exoplanet stack up against some of our neighbors? Well, Mars isn't exactly livable either. It's the red planet, so you'd think it'd be hot most of the time, but it's usually freezing. Well, way below freezing. And if you're planning a weekend getaway to Mars, you can leave the umbrella at home. Nah, it doesn't rain rocks, and it actually hasn't rained there for millions of years. At least Mars has days and nights, and it's like Earth in other ways. Mars' equator is steamy hot, and it gets pretty cold at the north and south poles, just like Earth. Scientists even discovered old bits of carbon dioxide snow there. The entire planet is actually covered in carbon dioxide, with a splash of nitrogen here and there. Scientists even reported intense snowstorms on Mars. But because it's mostly carbon dioxide, it's not your typical snowstorm. It's more like a dry ice storm. That's the stuff they use in fog machines. Mars isn't the only place where climates are going cuckoo. Jupiter's famous for its gigantic storms. Not like the ones we know on Earth. I'm talking about storms that last for centuries. The Great Red Spot on Jupiter is actually a 400-year-old storm, and you could fit 4 whole Earths inside of it. So it's been around for a while, but it's nowhere near as intense as the storms on K2. Venus also has intense rain, but it's not made of rocks. It's sort of worse. It rains sulfuric acid. That stuff can give you severe skin burns and rip nasty holes through your umbrella. Venus's atmosphere is filled with carbon dioxide, which acts like a net to trap in the sun's radiation, and it's insanely hot. No magma oceans, though. Mercury is the closest planet to the Sun and doesn't even have an atmosphere. That means no storms, clouds, rain, wind, whatever. Mercury is kind of like a desert here on Earth. No water vapor and no rainfall. That means temperatures shoot up during the day and drop like crazy at night. The K2 exoplanets, like the most extreme parts of all of our solar system, all rolled into one scary planet. But we're not headed there anytime soon. We haven't even been to Mars yet. That's all way off in the future, and 200 light years is a really long travel time. If we're going to move anywhere anytime soon, we'll probably want to set up camp on the moon. No magma oceans, no warp speed winds, nice temperatures. So, where would we even start? Well, the main issue is that drones and remote-controlled robots are getting more and more advanced. It's way cheaper to send them over to map out the moon for us while we're safe here on Earth. And if we ever want to begin space exploration for real, we'd need a proper space base. And what better place than our little shiny moon? So, why do we even study those far-off planets? What's the point? Well, planets are like people. They're all different ages and live in all different places. The more of them we study, the more we can understand why there's life, aka us, on Earth and not on any other planet so far. When we see crazy new planets, we get crazy new ideas, which can turn into awesome inventions that make our lives easier. Even just going into space gives us new ideas. Scratch-proof lenses, some firefighting equipment, water filtration systems, wireless headsets, invisible braces, that tiny vacuum you use to clean those crumbs in from between your couch cushions. They were all invented to help astronauts work better in space. And now they make our lives better every day. Maybe we'll figure out a new energy source someday, thanks to a far-off planet or star. Or we might discover a new compound that will make our buildings stronger or more energy efficient. For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye, if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye, because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbits that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system. At the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our Sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seems like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination. And they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system. But this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth, and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest, and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years. Earth, home, the third blue rod from the Sun. The only known planet where life can thrive. We have around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide, give or take. The perfect balance to support our respiration. The troposphere is the lowest and densest part of Earth's atmosphere, 5 to 9 miles thick. It's the part of the atmosphere that keeps changing our weather. For any life to exist, we would need this atmosphere and the same combination of gases to breathe. If all the planets in our solar system were combined to become a mega-Earth, then humans wouldn't have evolved the way we are today, and we'd have a very different planet. If we take the landscape of Mars, we'll only have solid land without large bodies of water. Earth is the only planet in our solar system with bodies of water. One of the first wonders to see will be Olympus Mons, the largest volcano in the solar system. It towers Mount Everest by a long shot at 78,000 feet above the ground. Velis Marineris is a group of canyons that make the Grand Canyon in the U.S. feel like an average one. This wonder stretches for almost 2,500 miles and goes more than 4 miles deep. On top of these epic terrains, there's plenty of other grand-scale locations on Mars that are way bigger than the ones on Earth. The planet might be as large as Jupiter. If the Earth were the size of a grape, then Jupiter would be the size of a basketball. We'd have the size of Jupiter and the rings of Saturn floating around us. The rings may seem like some large chunks of rock in the air, but they're actually ice particles in chunks of iced rocks. They range from the size of pebbles to car-sized ones. Saturn's rings are supported by the unique gravity in the region. With a lot of these ice rocks floating in the sky, there won't be much sunlight entering the planet, which means the planet will always be colder than usual. Not to mention the many moons it has. Our megaplanet could also have many moons circling above us, contributing to the tidal waves. Jupiter is known for the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. The people of Mega-Earth will settle far away from it. Mercury is a planet, but looks like the moon due to all the craters lying around. That's because of many asteroids and comets striking it over billions of years. But the landscape here mainly consists of mountains, highlands, cliffs, and valleys. The Calorus Basin is almost 1,000 miles wide. They believe it was formed by a comet. The deserts on Earth are mainly hot and consist of dunes of sand, but they also have flat plains and small hills. The largest desert in the world is the whole Antarctic continent. Mercury has no atmosphere to trap any heat, so it gets really hot when the sun is facing it and freezing cold when the planet turns away from it. On this combined mega-Earth, the deserts will most likely have a similar landscape to that of Mercury. The animals living here will probably be something like giant scorpions and desert snakes that soak in some sun during the day and go out hunting at night. But the soaring day temperatures would melt anyone walking. And even though Mercury is the closest planet to the Sun, it's not the hottest. Venus has temperatures of nearly 900 degrees Fahrenheit. Scientists believe that the lands here are flat because of the extreme temperatures, but it's not all flat, with some volcanoes and highland areas. We can probably find this terrain and climate near the equator, since it's always hot there. Humans can't live there unless they build special domes to sustain life. But since the planet is now huge, not all its territory needs to be populated. Some areas will have the proper atmosphere for breathing, but some places might not have such luxuries. Over at the poles, the climate will most likely mimic Pluto's, even though it's not technically a planet anymore. In 2006, they officially declared it a dwarf planet, and it's even smaller than the Moon. There's not much known about this little mini floating rock, except that it's composed of around 70% rock and 30% ice. Scientists believe that a part of its surface is covered in frozen nitrogen, solid methane, and carbon dioxide. Since the megaplanet is huge, gravity might be quite strong here. Jupiter's gravity is enough to double your weight. Humans will most likely be really tall and mega-sized to match the big planet. Even the oceans will be huge. Our oceans will look like little lakes compared to what Mega-Earth has in store for us. Humans need something close to 24 hours in a single day. Our bodies adjusted to it quite well, but it wouldn't affect us too much if the day had a few extra hours or a few hours less. We can't live on any other planet without wearing the proper gear. We wouldn't last more than a few seconds in places like Jupiter, Neptune, and Saturn. It's possible to last as long as you can hold your breath on Mars. The atmosphere is thin and the gravity is similar to ours, but you might freeze. Even though it's a red planet, it's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and the sunset. Ancient civilizations wouldn't have been as diverse as they were on Earth, since the extreme terrains and conditions wouldn't have allowed for discovery and training. But eventually, as humans developed special technologies for certain areas, different cultures would emerge. Many animals would also evolve in specific and unique ways, but because of the planet's enormous size, isolation, and being on top of the food chain, would let certain animals be around since the beginning of the planet without evolving. So it's possible that this mega-Earth might have ancient dinosaurs roaming around, and they'd be even bigger than the ones on Earth. And even though there's a high chance that some humans might be physically different than each other, there might even be more than one species of humans living on opposite ends of the planet. Because of the isolation, they evolved in their own ways according to their surroundings. Over the centuries, technological advancements would spread different cultures around, and we'd be more open to each other. Neanderthals and Homo sapiens once lived side by side and were considered as the two species of humans. Neanderthals were intelligent and used tools for hunting and drawing. Homo sapiens were survivors and wandered around to discover new land. There could be two dominant human species and other minor ones that live in certain areas on Mega-Earth. They'd be bigger, tougher, and faster than us. The ones who live by the trees would have elongated limbs to stretch out and swing from tree to tree. The ones that live in savannas will probably run really fast and have long legs for that. Countries and cities will be bigger than what we have on regular Earth. A country can be as big as Earth itself. The human population can reach tens of billions. Special transportation technology might be invented for people to travel from one continent to another. Covering those distances can take months or even years if using regular aircraft. High-speed trains that travel so fast over land, and rocket-like planes going through the sky. Traveling through oceans will require extremely sturdy ships. Traveling through the Atlantic Ocean is already scary for many, so imagine going on a voyage across a body of water that's potentially 8 times the size of Earth. We're gonna need a bigger boat. There'll be areas to avoid, like the red spot with its perpetual storms raging on, but the tourist industry might have some room for anyone who wants to see it. Living on such a huge planet is unlikely going to become a reality for most of us anytime soon. But scientists are already discussing moving to other planets to find a new home for humans.